here's just a brief note about the trapezoid rule. Seems like some students are still confused about how this works. Suppose we have an interval from A to B. So A is the left hand endpoint here, and B is over here. And we want to find out the trapezoid approximation to the integral. So the integral from A to B f of x dx is approximately, let's see, where's approximately, equal to the nth trapezoid approximation. What is that? I'm going to try not to cough here. I'm even sicker than usual here. We want to look at the trapezoid approximation, and the long-winded way, and the only way if you have unequal spacing, is to really just take the area of this trapezoid, average of left and right heights times width, average of left and right heights times width, average of left and right heights times width, etc. But there is a shortcut in the case of equal spacing, and I just wanted to clarify that. You take, one way to write it, excuse me, is you take delta x, and then we're going to add, we're going to multiply that by, what happens is that each of the internal boundaries, like this point, it gets measured as, it's the average of left and right for this guy times delta x plus average of left and right for this guy times delta x. So it gets counted with 1/2 from the average, but it gets counted twice. So everybody in here gets counted just as normal, as if it were just one of the left or right endpoint methods. The only exceptions are the left hand, the far left, x0 or a, and the far right, xn, in this case x4, or b, which only get counted with a 1/2. And so I like to write it as, just separate those guys out, f of x0 plus f of xn, and then just so you're taking the average of the first and last, and then all the other guys. And what people were getting confused about is, what is the x0? It really, x0 isn't the first internal one. It's actually a. It's the left-hand endpoint. So we could actually write it in a slightly different way as, I could just call this a. So you're going to take the average of the function values, the far left and far right, and then just add in the function values in the interior times delta x. Remember, this only works for equal spacing. Tabular data often has unequal delta x's from subinterval to subinterval, and then you just have to go back to the basic idea of trapezoids. Now, the way you'll usually see it, like in a book, is they factor out the 1/2. And then this whole thing becomes f of a, and they usually move the b over to the end, which is a natural place for it. And then everything else gets multiplied by 2. And that's fine as well. But the main thing that I was seeing people doing was getting confused as to which ones you actually put in, and basically forgetting the very first one. So try not to forget the first one. Okay. Now, of course, for the midpoint method, people are getting pretty good at that. There, you actually are evaluating like right here, right here, right here, right here. So you've got to divide up into the delta x's, and then you've actually got to find those midpoints. For small n's, you just do it by hand. Remember, the thing I always say is, even if you're not graphing the function, which you don't often have to do, at least draw a number line from A to B, and just draw the divisions. It's much easier to get it in your head that way. Okay, I think that was the only point I really wanted to make, is be careful about not forgetting the first and last point.